Now we're going to look at our first type of problems where we're going to learn how to actually factor. Before we do this, we're going to look at what a GCF actually means. So GCF stands for greatest common factor. And then let's look at an example so we can understand what that actually means then. So if I have, let's say we have 12 and 18. And let's list all the factors of each. So we got 1 and 12, 2 times 6, 3 times 4. And then for 18, 1 and 18, 2 and 9, 3 and 6, and that's it. So 12 and 18 have a couple different factors in common. They have a 1 in common. Well, every number is going to have a 1 in common. They have a 2 in common, and they have a 6 in common. So if I'm looking for the greatest common factor, so I'm looking for the common ones, they have 3 in common, 1, 2, and 6, but I want the greatest one they have in common. So the greatest one they have in common would be 6. So of 12 and 18, the greatest common factor is 6. So if we're looking for the GCF of a number, we want the biggest factor they both have. So biggest factor of both. And then we're also going to be looking at finding the GCF of a variable, especially like we look down here at number 3 and 4. And that works a little bit different. It's actually going to be the smallest exponent. So if I have x to the second and I have x to the third, x to the second would have 2 x's. X to the third means I have 3 x's. And what I'm going to start doing here is I'm going to start taking out pairs. So I can take out 1 from each. Then I can take out a second one from each. But I can't take out any more because even though there's another one here, there's not another one on the x squared side. So the most x's I could take out of both would be x, with 2 x's, which would be x to the second. And then the shortcut then is I look at the smallest exponent. Between 2 and 3, the smaller exponent is 2, so I can take out 2 of the x's. Okay, so determine the greatest common factor. So we don't have to factor these, we're just going to find out what that greatest common factor would be. So 8 and 12. If we need to, we can write out the work. List the factors of 8, 1 and 8, 2 and 4. Factors of 12, we just did over there, so it's 1 and 12, 2 and 6, 3 and 4. And we're looking for the biggest one they have in common. And the biggest one they have in common is 4. So the GCF would be 4. For number 2, we're going to do the same thing for 12 and 36. And if you are, again, we just did 12, so I can just copy this one down. If you're really good at knowing your factors and your multiplication facts, you could probably do this without having to do all this work every time. But there's nothing wrong with writing out all the work if you need to. Okay, so if we're not sure if it's a factor, what we're going to do is we're going to take the number we're trying to do, so in this case 36, and I'm going to keep dividing it. So 36 divided by 2. If you get a whole number answer, then it's a factor. If you get a decimal answer, then it is not a factor. So if I do 36 divided by 2, that is 18, which means 18 and 2 are both factors. If I do 36 divided by 3, I get 12, which means 3 and 12 are both factors. If I do 36 divided by 4, I get 9, so 4 and 9 are factors. If I do 36 divided by 5, I get a decimal. So that means that 5 is not a factor. So then I move on to 6. 36 divided by 6 is exactly 6. The reason I like writing the factors like this in these lists is because I go down the left side here, and then I loop around, and once I get back to this number here, then I don't have to check all those numbers in between here. So I don't have to check 7, 8, or 10, 11, because if there's no factor in between 1 and 2, then there's no factor in between 18 and 36. So like here, I go down 1, 2, 3, I loop around. Well, there's my 4, so I'm done checking. Right down here, 1, 2, I need to check 3. 3 didn't work, so then I'm already did 4, so I'm done checking. All right, so let's go back to look at number 2 then. So here's all our factors. The biggest one they have in common is 12. So So the GCF would be 12. In number 3, this one's a little bit different, has a negative sign in front. Anytime there's a negative sign in front, I want to also factor out that negative sign. And then the only thing that I can divide both 8 and 10 by is 2. So the greatest common factor will be, instead of 2, negative 2, again, because there's a negative sign in the front. And then on number 4, if you need to, you can list out all the factors of 9 and 3 like we did up on numbers 1 and 2. The biggest number I can divide them both by will be 3. Okay, now let's go back and look at number 3 and then number 4 again, because these also have a variable part. So the difference is, up here in number 1, the 8 had an x, but the 12 didn't. So there were no x's in common. I couldn't take out an x. Same with number 2. The 12 had the x, but the 36 did not. Okay, so what's different down here in number 3 is both that 10 term and the 8 term, they both have an x. Remember, we want the smallest exponent. So that's x to the 1, which means I can take out an x to the 1 also. And in number 4, the smallest exponent is the 2, which means I can take out an x to the second. So the full GCF on number 3 is negative 2x, and the full GCF on 4 is 3x to the second. Okay, so once we can find the greatest common factor, then the next step is to actually finish factoring the problem. So let's look at number 5. Again, we're going to find the greatest common factor between these two terms. The biggest number I can divide them both by would be 6. I'm going to write that down here. Okay, and then, so what we're going to do is we're actually going to find what did I multiply 6 by to get to that 6x plus 18. One way to do that is that once you find the GCF, divide each of these by that greatest common factor. So 6x divided by 6. So this is exactly what we just did in our last chapter. And that's going to be 1x, and 18 divided by 6 is 3. And there's a really quick way you can check our work. If I distribute this and do my multiplication like we did in our last chapter, 6 times 1x is 6x, and 6 times 3 is positive 18. So if we did this correctly, when I do that distributive property, I get back to where I started. If I don't, then I have an error somewhere. Number 6, there's a hidden 1 here. Well, the only thing that I can divide by 1 and 8 is 1. So I can factor out a 1. But then with the variables, you want the smallest exponent. So the smallest exponent is the 1, so I can take out an x to the 1. And you don't have to write the 1, that's optional. And then, again, that's like dividing both of these by that 1x. 1 divided by 1 is 1. X squared divided by x, remember you subtract the exponent, so 2 minus 1 is 1. 8 divided by 1 is, negative 8 divided by 1 is negative 8. And then subtract the exponents. But remember, when we get 0, 1 minus 1 is 0, then we don't need it at all. And I can quickly check 1x times 1x is 1x squared. And 1x times negative 8 is negative 8x. Number 7, I can factor out a 5. And I can factor out an x. And then to see what goes in the parentheses, if I divide both of these by that GCF, by that 5x, 15 divided by 5 is 3. X to the second divided by x to the 1 is x. Because again, we're subtracting those exponents. 2 minus 1 is 1. Negative 5 divided by 5 is negative 1. Subtract the exponents. 1 minus 1 is 0, which means we don't need that. And then out of these, I can divide them both by a 6. But remember, with that leading negative sign here, we want to factor out that negative also. And then they both have x's, so I can also factor out the smallest exponent of an x, so that's to the second power. And then to find out what was inside the parentheses, we divide each of these by our GCF, so that was negative 6x to the second. And do that division just like we did in the last chapter. Negative 12 divided by negative 6 is positive 2. Subtract the exponents. 3 minus 2 is 1. 18 divided by negative 6 is negative 3. And 2 minus 2 is 0, so we don't need the x there. And again, I could easily multiply this to check. So negative 6x squared times 2x is negative 12x to the third. And negative 6x squared times negative 3 is positive 18x squared.